Welcome to operators. The reason why you need to know about operators is it rhymes very well with variables, whereby once you've understood what variables are from the previous session, then you need to know how to do something with the said variables. So let's go find out what operators are. What you'll see them to be is their special symbols. Just look at here. The red one will do. There are special symbols that you use to perform operations, and these operations are specific because we'll look at arithmetic operations, we'll look at assignments, and so on and so forth on one, two, or three operands. So we'll see what operands are and then return a result. So that is what an operator is. If you understood 1 + 1 = 2 in maths, then you will really find operators to be very smooth for your learning. Now, there is precedence of operators. That is, they are those that will be prioritized. If they all exist as one, they are those that will be prioritized over others, and this is the precedence. So let me just expand this table. Feel free to take a screenshot if you want. This is the precedence, but there is a link in the description, and in fact there are links all over where you find the source of this table. The only thing I think I added is this evaluated right to left, unlike the others that are evaluated left to right. So you can pause and take a screenshot of that. We'll be focusing on the most common ones. So let me just go to the code demo. Most of these are things that we already have seen, but we're getting to close to finalize on that discussion. So we are working with this variable, simple assignment, and we are setting the value to 5. So assignment operators from right to left. This is an assignment operator. We start from right to left. So that means we are setting the value of 5, or the integer 5, to the variable simple assignment. Okay. And if we run that, then we expect that the simple assignment value is 5 to be visible. There you go, the simple assignment value is 5. Moving on to this other part, arithmetic operators. We started with multiplicative operators, the first one being the multiplication operator, which is represented as an asterisk in Java. So we have this operand here, we're setting the value integer 6 to operand, variable operand. Then we are taking operand and multiplying it by 3, then assigning that to multiplication. So 6 by 3 should be 18, so this should give us, for multiplication 6 by 3, we have 18. Running that. There you go. Okay. Up next we have the division operator. So these are things that I think you already know, probably already, unless you've not done math, which is very unlikely. These are things that you already know from basic mathematics. So divide is written like this. We are taking the operand 6 and dividing it by 2 and setting that to a variable divide. So that should give us 3. From division 6 by 2 we have 3. Running that. There you go. Okay, the remainder operator. This one is sometimes known as a modulus operator if you're coming from a different program. What it does is it will represent the remainder of the outcome of this dividing the operand with whichever value. So for example, operand being 6, when you divide it by 5, the remainder is 1. So if you work with this remainder operator, what will be returned as the output is 1. So from remainder 6 modulus 5, we have remainder which should be 1. So I'll run that. There you go, 1. Okay. Next, addition. So 6 by 4, expect it to be 10. Pretty easy rules, yeah, as you would normal math, and then to the concatenation. So you can work with the additive operator to combine two strings, as you see in here. So this is the first one, and this is the final one, the first part and second part. So you can add first part and second part and save it to all parts string, to a new string, and then when you print that out, you should see this is first concatenated with second. There you go. Okay, moving on to subtraction. So you check the operand, subtract a value, and save that to subtraction. Then if you print subtraction, you should see 1, since it's 6 minus 5. There you go. Then to compound assignments. So with compound assignments, they were designed to have compact code, because in some scenarios you might find you would have to write this, something like this, where you have a variable and you're taking that variable and adding something to it. Like in this case, we are adding 1. So in such a case, instead of having this repetition of simple assignment, yeah, in such a case, what you would do is to take simple assignment and we put the compound assignment like this. So what will happen is it will take this value and then it will add it to this value. So it works the same way, but there's less repetition and your code is more readable and compact. So you will see this in any of these. So it could be a plus, a minus, or rather, to be more precise to Java terms of addition, subtraction, multiplication, division, remainder, and the bitwise ones that I'll talk about in a few. So this should give me 6. Yeah, there you go. Yeah, simple assignment was initially set to the value of 5. By the way, it's just up here. Simple assignment. Okay. Then we have unary operators. So they are unary because they only require one operand. Oh, and by the way, I forgot to tell you what an operand is. An operand is a value that is involved, value or values that are or is involved when you're working with operators. For example, since I worked the word operand so far here, but all these are operands. For example, this is operand and this is an operand. If it's just one, we call that unary operators, or rather, unary operators just require one operand, like you're seeing in this case. If you want to have a negative value, you can just negate it like this, and in that case it will just return the negative value of the result. For example, negative value. To negate the value of subtraction, which we got from here. By default, everything is positive value, so it will be redundant to work with plus, unless you have your reasons anyway. Okay, and finally, for this part, we have boolean. So boolean is true or false, as we learned with variables discussion on data types. So if you have it as true, then you can work with a logical operator to invert it. And in this case, if it's currently positive, then you work with this logical operator, which is actually, we should have indicated it here, an exclamation mark in typical English language, then it would be inverted to false. Let's find that. There you go. So this is currently true and now it's false. That's the first part. Okay, so there are some things I'd like us to know, and it's in regards to the pre and post increments and decrements. So let's check that out now. We have postfix operators, and one of them is the increment operator, but there's also the decrement operator. What it's supposed to do is to increment by 1. We'll see this a lot when we're working with for loops in a bit, and sometimes logical conditions, but let's go one step at a time. So this is the syntax: expression plus plus, or expression minus minus. If it's applied after the operand like this, it's a postfix. If it's applied before, it's a prefix. So let's find out what we are supposed to know about this. So we have int I. So we have 3 set to the variable I int. Then we're incrementing it, so we're expecting that this should give us a 4. So if you print I, it should give you 4. Let's see. 4. Okay, work with me now. Right, so we have the second bit, prefix operator, which is plus plus expression. It's applied before the operand, so it's hence the name prefix. Now we have a 4. I is currently 4. If we increment it, then I should give us 5. So if I print this, I expect it to be 5. Okay. 5. Alright. I continue on with this. Up next, the postfix operator. If I was to take the current value of I, which is 5, and I do a prefix increment on it inside system out, then I should expect to see 6. Yeah, makes sense. In fact, since this is adding it by 1, so there we have it. Now, thing is, when you're working with the postfix one, not the prefix one, when you're working with the postfix one, you might expect that it will give you 7, but that is not the way it works. The postfix operator evaluates to the original value in this kind of setting, yet the prefix one evaluates to the incremented value. So this worked correctly as you expected. Okay, they're all working correctly, but this worked as you expected, whereby if you increment 5 by 1, 5 by 1 you get 6. And this one does not work as you expect in this scenario. If you increment it like this as a postfix, then it will evaluate to the original value, which is a 6. So it's printing 6 twice. If you work with the exercise and you'll see a question asking why does this evaluate to 6 instead of a 7, that's the explanation. Okay. Alright, but if you go ahead and print I, then the value would have been reflected as 7. Yeah. So sometimes it might not matter the one that you choose, especially if you're working with code in general, but if it's part of a big expression, then it might have some significant difference. So it's up to us to weigh on which one we would like to work with now. For your own practice, please do the same for decrement operators. You can just work with the same value from GitHub. I have this code on GitHub, okay, in the GitHub link. Then you practice with the decrement operators as they are and see how that is, but you expect them to behave the same. On the second last bit of operators, we have equality and relational operators. Again, very easy things if you did basic maths, or at least if you understand English. Okay, so we have 1 set to variable value 1 of type int and 2 set to variable value 2 of type int. We will practice with equals, not equal, greater than, less than or equal to. And we should probably have expectations of how this will work out from our basic knowledge. Yeah. Now later on we'll talk about some more about if-else statements, but we'll make it fast here, so work with me. So if value 1 equals to value 2, it should print value 1 equals to value 2. However, that's not true, so this shouldn't be printed. If value 1 is not equal to value 2, then it should print it's not equal to, so we expect that to be printed. If value 1 is greater than value 2, it should print the same, but value 1 is less than value 2. So this one is the one that will be printed. If it's value 1 is less than or equal to value 2, then it will be printed. So we're expecting some of the statements to be printed and others not true. One, two, three. We are expecting some of the statements to be printed and others not true. So I'll just run this. There you go. Value 1 is not equal to value 2. It's less than value 2 and it's less than or equal to value 2. Correct. So that's how you work with equality and relational operators. They'll come in very handy later on when we discuss the if else statements and the like. Next, we have conditional or logical operators. Let's see how they work. If value 1 equals to 1 and at the same time value 2 equals to 2, then print this. So we expect this to be printed. The OR statement will print if one of them is true. It doesn't have to be all of them. So this will only work if all of them are true. This will work if at least one of them is true. So like we're saying here, if value 1 equals to 1 and if value 2 equals to 1, then print this. So it will still print it because one of them is true if this value 1 equals to 1. There you go. Value 1 is 1 and value 2 is 2. Value 1 is 1 and value 2 is 1. Or value 2 is 1. So there you go. And that's how it works. Just to make sure this is clear, I'll change this to a 1. Then we'll see. It shouldn't print this because an AND, logical AND, should only work when all of them are true. There you go. So it's no longer printing that. Let me just turn it back to a 2 and continue. So when we talk about the if statements, we'll find out that there's if then else statements, and if you want to have a shorthand for that, we will work with the ternary operator. It's called a ternary operator because it works with 3 operands. Suppose you have int result, variable result of type int, then you have variable some condition, boolean variable some condition, and it's currently set to true. Then you could, if you want to check whether a condition is true and you have it do something, and if it's not true you have it do something else, you can work with the ternary operator instead of working with the if then else statements. For example, if some condition is true, then print value 1, otherwise print value 2. That is how it works. Anything that comes before the question mark, we check the condition if it's true. The first value after the question mark will be evaluated, otherwise the value after the full column is the one that will be returned. So we have we're setting that to the result, to the int result, the return of that to the int result. Of course, the values are integers, so this makes sense. If this was a string, then we would expect to see errors because value 1 and 2 are integers. Let me just turn that back. So what I should see is this is true as you've seen here. So 1 is what will be printed, not 2. There you go. 1 is printed. So you'll work with that if you want to have compact code instead of if then else. I would have shown you the alternative, but I think it's pretty much self-explanatory, and then we'll talk more about it later, so I'll leave it as it is for now. There's also the type comparison operator. It's called the instance of, and in this case it can check if an object is an instance of another. So if you were in the session about objects, then this will be smooth for you. If not, you can just pause and review objects first before you come back, but you can start from here and then you figure out your way. So we are instantiating class operators 1 and setting it to object 1 And then we're instantiating class child, which is here. It's just a simple empty class that is extending operators 1 and it's implementing my interface. So we are instantiating it and setting it to object 2. Now let's compare the two objects. Object 1, which is an instance of operators 1, is an instance of operators 1 that should be true. Object 2, object 1 is an instance of child that should be false. Child is the one that's an instance of object 1. Object 1 is an instance of my interface, should also be false because my child is the one that's an instance of my interface. Object 2 is an instance of operators 1, true because it's extending operators 1. Is it an instance of child? Yes, because in itself it is an instance of the class child. Then is it an instance of my interface? Yes, because it is implementing my interface. So if you run this, you will see true, false, false as expected, and then the rest are true. Okay. Finally, we have Bitwise and BitShift operators. Now, these ones are rarely used, and even if you spend a lot of time going through them, you will forget them before you ever get to use them, probably, or more often than not. Like, there are notes that I made, and sometimes I look at them and they look very new to me. So these are the kind of things that it's good if you refer to them. However, I have included this. If you're interested in finding out more about it, please work with this. It's still in the link in from GitHub. And then challenge yourself or look around. You might find that there are few errors in there. I'm not really certain if it still works, because again, it's not really something that you get to use every now and then. But you can look at the notes so you'd get to understand at your own time. And I've also included that in the independence practice if you're interested in that. Otherwise, I'll be seeing you on the next one.